And today, to kick things off, Ryan and I are going to do a little bit of a presentation here about analytics on JanusGraph.
Yeah, I'm Ryan Stauffer. I'm the founder of Enharmonic. And what we do at Enharmonic is we try to provide some tools that make it easy for companies to onboard new data, connect that data to existing data sources, and then gain insights from it, run analytics, export it into machine learning pipelines, things like that.
Great, thanks, Ryan. My name's Ted, as I mentioned. I'm a data architect over here at Expiro, and also a member of the JanusGraph Technical Steering Committee. I work on a variety of projects, but a good chunk of them are graph projects. So thanks for joining up today. So first of all, as a level set here, I just wanted to spend a little time defining even what I mean by analytics at the start, because this can, I know, probably is a bit of an overloaded term. It can mean different things to different people. So in the graph world, when I think about analytics, at least, probably the first thing that comes to mind, and I think this is probably generally true for folks, is graph algorithms. So one of the reasons people get excited about graph databases, I think, is they hear about all these interesting different algorithms they can run on their data after they get it into a graph. So examples of graph algorithms are, everybody's probably heard of Google's PageRank, which is a centrality algorithm. Connected components, there's clustering algorithms, path calculations, all sorts of things where you're probably looking at some very large portion of your graph, maybe even all of your graph, and then either computing some metrics about it or finding paths in it that may be of interest to you. So that's the first category. The second category, I'm just going to call OLAP, which sometimes these two things get, I think, conflated, but OLAP, at least how I'm talking about it here, is more akin to what you'd be used to running over in the relational database world. So you may have put your data into a graph database, but you still may want to serve aggregated information from that data up into, say, a business intelligence type application, or roll things up into a format that would be good for reporting. And so those are queries where we're still going to hit some large portion of the graph, probably maybe still calculate some metrics and things like that, but we're not really running any graph algorithmic components. A classic, very simple example of this that people sometimes run into as a pain point with JanusGraph is you start up JanusGraph, you load a bunch of data into it, and you try to just count the number of vertices in your graph. Now, if your graph's small, this will come back no problem. If you have a very large graph, it just plain won't work just using regular old JanusGraph, and you need to start to bring some other tools in. So even if maybe you don't think you're using something that could require, say, graph analytics, you very well at some point may need them just to do some basic counting type operations. Another way I like to kind of compare and contrast, just because a lot of people who use graphs, of course, come from the relational or other database world, is one difference between graph analytics and relational analytics is in a relational database, this isn't always the case, but generally speaking, especially for kind of small to medium-sized data sets, you can run analytics in your relational database, but you may change the model. You may change how you're storing that data. So you could think of, in a relational database, you may start out with an OLTP model that's more normalized, and then to run analytics and roll-ups and OLAP, you'll produce a new model, maybe a star schema, a dimensional model. So there's a change in the model, but you can actually run in the same engine. So you could say I'm using SQL Server for OLTP and for OLAP. In the JanusGraph world, and this is true for a number of other graph databases, it's kind of flipped. You don't actually change your graph model; it stays the same, but you execute your queries in a different actual execution engine than just the regular JanusGraph execution engine. So now the caveat here, of course, is now we have all these other cool analytical databases in the RDBMS world. Redshift, etc., where they have different execution engines. But again, in many cases, you can actually use the same engines, but you just change the model. So for folks that are new, maybe you're new to JanusGraph or just started kicking the tires, I just wanted to make a brief call out to a very important component to JanusGraph because we'll be talking about it today, which is Apache Tinkerpop. This is a set of tools that JanusGraph is tightly integrated with, and this is where Janus actually gets its analytic computing capabilities from. So in the Tinkerpop world, and you can go read more about this in the Tinkerpop docs, there's a concept of a graph computer. A graph computer is basically a programming model that is based upon the same vertex-centric programming ideas that were developed in Google's Pregel paper. They built this very large MapReduce-based distributed graph computing framework. So Tinkerpop actually incorporates that into its graph computer programming model and provides a number of different graph computers or different execution engines where you can run graph analytics in OLAP. So we have a Spark graph computer that lets you run these things in a distributed multi-machine fashion. And then there's a TinkerGraph computer that's bundled. This is a single machine, but multi-threaded. And then lastly, this isn't documented in JanusGraph very well. It's kind of, I don't think it's in the documentation at all, but there's actually something called a Fulgora graph computer in JanusGraph. It's JanusGraph specific, but it's single machine and multi-threaded. So there's a few different options for executing graph algorithms, but we'll be focusing on the Spark graph computer today. So JanusGraph is integrated with Spark in basically this way. I'll walk you through kind of the life of a JanusGraph OLAP query just real quickly here. So let's say you start up your Gremlin console. Instead of getting an instance of a JanusGraph factory, we're going to actually open up a Hadoop graph using this graph factory .open instead of JanusGraph factory. Then we can actually get a regular old traversal source, just like we were getting an OLTP traversal source, except we're going to say, hey, let's execute this with Spark. And then let's run just a really simple query. Like I want to do a count of all the different labels in my graph. You know, maybe I have 1 million people, I have 1 million products. I want to roll that count up. So this is a query that you could execute in a small graph in OLTP mode, but if you have a large number of vertices, you're going to need to use something like Spark. So what happens is this Spark job gets submitted to the Spark cluster. At that point, if you look over here on the right, the Spark cluster is going to pull data out of the JanusGraph cluster. So let's say we're running on Cassandra. Now we're going to use a class called the CQL record reader, or maybe the Cassandra binary record reader. But basically the idea here is this execution of this traversal is no longer going to happen in JanusGraph. JanusGraph is going to be the source of that data. So we're going to pull that data up out of JanusGraph into Spark RDDs. At that point, then the Spark workers are going to be running, processing those RDDs, and this traversal vertex program is going to be executed, which is going to take our human-friendly G.V label group count and turn this into one of these Pregel-style bulk synchronous parallel vertex programs. That will then run, and then our results will then be returned back to the console for us. So now I'm going to turn this over to Ryan, and he's going to discuss some of the challenges of this setup with JanusGraph.
Hey, thanks, Ted. Yeah, so like Ted mentioned, we have these OLTP and we have these OLAP workloads. In theory, we want to be able to run them both on JanusGraph. And so deploying a large JanusGraph instance purely for transactional processing is pretty straightforward. You know, it's not a big deal to scale up a pretty robust server instance where you back it with like Scylla and Elasticsearch. They'll give you, you know, low single-digit millisecond symbol traversals where you're pulling out, you know, maybe 1 or 2 elements at a time, and then low double-digit millisecond complex traversals where maybe we have a lot of filtering and project operations. But the issue is that if we want to truly get a lot of data, so if I want to start looking at and retrieving thousands or millions of data points, you're not going to get that performance from the normal OLTP setup. Perfect. And so in a perfect world, what would we be wanting if we had everything we could possibly hope for when it came to JanusGraph OLAP? And honestly, I think it comes down to basically two things. One is that we can have reasonable execution times, where we account for the data set in question. And the second is that we can scale that execution, pretty linearly as we increase the number of workers. So once we have a setup that we like, in theory, we'd like to just be able to throw more compute at it and have it go faster. Now, I do want to dig into what I mean by reasonable execution times. Obviously, we're talking OLAP versus OLTP. And so just like any setup where you're talking OLAP versus OLTP, there's probably going to be a little bit of additional overhead. If we think of any of these parallel computing frameworks, fundamentally, like, you have to spin up a lot of stuff just to run them. There's a lot of pieces to Spark that make it a robust execution engine, and those take a little bit of time. But still, we should have pretty quick returns of answers to clients, because we're still talking, this quote unquote online processing, as opposed to, some sort of big offline batch thing where we're going to let something run and crank away overnight and then get a result back at some time in the future after many meals and smoke breaks. If we can get it within minutes, or preferably even seconds, that becomes much more feasible to use as a solution for different client programs. And then the third bit is actually just harking back to something Ted touched on at the beginning, which is there is this difference between a graph global, canonical graph algorithm like PageRank, or like some of these shortest path algorithms, where we generally are going to touch every single vertex in the graph. And that's just, by its inherent nature, going to take a lot of time. A lot of common business OLAP logic actually doesn't need to do that, because businesses are generally modeling pretty heterogeneous data in their graph database. You have sales, you have customers, you have products, you have maybe some email marketing data. And generally for a single type of OLAP query, you're only going to touch a subset of that data. So in theory, our execution time for this business logic OLAP traversal should be a subset of the time that it would take to run one of these graph global queries. Can we go to the next slide? Thanks. And so one of the biggest problems that you might run into if you use Spark Graph Computer to execute this sort of OLAP logic is this. And I do want to give a shout out, by the way. The version 0.4 release of JanusGraph does now include CQL support for OLAP, so CQL support for Spark Graph Computer. I think it was Florian who initially submitted one of those pull requests. So thank you very much. That's definitely very helpful and definitely facilitates a lot of the work we're talking about. But fundamentally, there's one issue with Spark Graph Computer, and that every time you run that, it's going to begin its process with basically a full graph scan, where it gets all the data out of JanusGraph to prepare for one of these graph global vertex programs. And the other thing it provides is a lot of expensive capabilities, which I'll go into some of, that we actually don't necessarily need for a traditional business logic OLAP query. And so both of those things really get in the way of that number one requirement, which is that we can execute one of these things in a reasonable amount of time. One other interesting thing is the way Spark Graph Computer works. The way you'll submit this traversal to be executed on Spark really doesn't leverage any of the intuition that a data science team in your organization may have built up. So for instance, they're used to using Spark SQL, maybe some of these other features, maybe they work with raw RDDs, but generally the way they're going to interact with these things as part of the Spark Graph Computer doesn't utilize any of that knowledge. So if they want to, maybe feed results out of the graph, out of the graph algorithm into some other, maybe machine learning, or maybe joining that and enriching that with another data source that lives in a relational set of tables or Parquet files, that's going to be pretty difficult out of the box with Spark Graph Computer. And so fundamentally, I think this comes down to there being basically a mismatch of capabilities with Spark Graph Computer versus what a lot of people may need on an everyday basis. And so, Ted mentioned Spark Graph Computer is built basically on this Prego model of doing things, which is that it's a bulk synchronous parallel processor, which basically allows you to have some workers, and during the course of processing, they're going to pass messages along, and then eventually they'll reach a barrier synchronization step where they need to make sure that every worker has reached that step before they go forward. And that's awesome if we want our downstream results to depend on these intermediate calculations we may need to do. But a lot of times for some of these business roll-ups, maybe a sales roll-up by customer type or a sales roll-up based on some email marketing that happened, a lot of that can be done without depending on these intermediate traversal calculations. And so in that case, what we're talking about actually looks a lot closer to a parallel external memory model, where basically we're going to have individual independent workers, and each of those never needs to communicate with each other, because fundamentally all they need to be able to do is read and write to this external memory. And if we think of JanusGraph as being that external memory, we can basically, in theory, distribute tasks to these external independent workers, and they'll run their sort of roll up on their segment of customers, for instance, and then they'll just return the results. Now, Spark Graph Computer does not do this out of the box, but I think there is a pretty straightforward, alternative Spark solution that doesn't require actually rewriting JanusGraph itself. And so I just want to walk through, sort of how that might work. And so, in theory, if we write this program, and this is not theory, this has been used and tested, and it works pretty well. So basically, we have 3 core steps, and then we have 2 kind of optional steps. So the first step is that we want to execute a filter step on our driver. And with that, we're going to create an RDD of internal JanusGraph IDs. And so that might look like, a G.V has where some field equals a value, and then we'll get the IDs as a result of that filter step. Now we want to distribute that RDD of those JanusGraph IDs to some number of Spark executors. And then when we get to step 3, what we're talking about is that each Spark executor is going to be able to execute this business logic on its unique set of IDs. And so for each ID, it's going to basically call G.V ID, et cetera, et cetera, et cetera. Do some sort of normal traversal, some grouping, some aggregations, things like that. But post that, we can basically execute any sort of additional Spark processing, because we're doing this in the form of a normal Spark program we might write in Java or Scala. And then once we're done with that, we can just write the results to a partition file, and we're kind of done. That now gives us a result that would look a lot similar to a normal Spark workload that your data science team is probably already dealing with. So from my experience, this can be pretty effective at parallelizing the retrieval of large amounts of these complex traversal results. And it's not that difficult to write. It's basically this pretty straightforward framework that once you have it in place, you can kind of plug and play any business processing logic into it that you'd like.
So another thing too that we're kind of, I think, keeping our eye on, and lots of JanusGraph folks are probably looking towards this, and is looking to the future, and we have the current TinkerPop 3 model, which is like what Ryan and I have been discussing, which is really awesome, and it actually does the ability to run like arbitrary gremlin queries in OLAP mode is pretty powerful. But then looking forward to TinkerPop 4, I think there's going to be even more really interesting options that when we integrate with TinkerPop 4, we'll be able to roll in. It's still very early days for this, but there's already a lot of work going on here. Marco Rodriguez, Stephen Mallet, and Daniel Cuppis, Josh Shinavir, and others are doing a lot of work here. And a few of the interesting things that I've seen so far are in addition of potentially new execution models. So for one, an actual single machine multi-threaded execution model for doing OLTP queries, but actually parallelizing them. So that's pretty interesting, especially for this kind of in between ground where we're not looking at the whole graph like Ryan mentioned. And then also a multi-machine actor-based distributed query execution model. So using something like Akka, for example. This would remove, well, maybe not remove the need for Spark for certain things, but would allow one to run something probably closer to a real-time query that was actually running across the entire graph cluster. Instead of, say, right now with Janus, you run an OLTP query, it's going to be executing in the Gremlin server where you hit that query, even though it's going to be pulling data from many different nodes. So this would be one way to move some of that computation closer to the data as we're running these queries, and I think would allow us to run larger queries that are touching more vertices in a more efficient manner. So if you're interested in watching this stuff, check out the TinkerPop dev list. Marco's already, and Stephen and Daniel have published a very cool spec for some other things kind of along these lines and related to TinkerPop 4. So definitely check that out. So in conclusion, I guess as Ryan mentioned, really right now there's probably no kind of perfect solution for OLAP on JanusGraph. No kind of one size fits all. There's bits and pieces that can be very helpful that we can bring together, but there's not really kind of one way to do it probably for all your use cases. But as he proposed, I think there's a number of kind of pragmatic ways that one can actually get a lot of this similar functionality, but have have better interoperability with current tooling and also better performance. And in a lot of cases, you know, when you're just trying to solve a business problem, that's a good way to go. So I think there's a potential bridge to some of these more future-looking improvements where folks could get started and have some benefits in the meantime. I think one thing Ryan has, I think rightfully so, is really interested in, and Ryan, not to speak for you here, so sorry, I kind of took over the conclusion slide, but benchmarking would be really interesting, and hearing about if folks are using JanusGraph and Spark out there in the community. You know, I know a number of people who are, but in general, I don't feel like I have a good feel or we have a good feel for what is the usage of Spark out there in the community. So we have a poll question at the end of this kind of along these lines, but we'd also just be interested in hearing about pain points or successes you've had with Spark. And then also I think our documentation could use some additional content targeted towards different personas, you know, people who are using maybe the output of JanusGraph and want to use it for doing analytics. So these could be data scientists or business analysts. I think there's probably a set of good instructions and steps we could put together to help people get started with these things in a pragmatic sort of fashion. So I think that would be really beneficial for the community. So so thank you very much. And at this point, I think we can take a few questions.
Great. So I will go ahead and read the questions out loud, and then any of our panelists can answer them if you would like to. I'm going to start by reading one that Becky answered via text. If you click on the Q&A box, even if you don't ask a question, you can still read what other people have asked if it's been answered. So Raul says how to implement high availability for JanusGraph like master save or cluster. And Becky said we have leveraged several clusters with the same HA storage and indexing backend. This essentially shifts the HA component off of JanusGraph to the backing technologies, Cassandra and Elasticsearch for us. But it will depend heavily on the storage and indexing backend that you use. So Ryan or Ted, I don't know if y'all want to add anything to that one.
No, that was that's a great response.
Okay, great. So our next question here says, are there scaling limits on TinkerGraph computer and or Fulgora Graph computer besides the size of the underlying machine? I'm thinking a 64-core VM could do a lot of OLAP rather efficiently.
Yeah, that's a great question. So I should have been probably clear with the TinkerGraph computer. The TinkerGraph computer if you've used Tinkerpop before, it comes with a reference graph implementation called TinkerGraph. So the TinkerGraph computer only runs only works with data stored in a TinkerGraph. So it doesn't have any interoperability with Janus. Having said that, the Fulgora graph computer, I haven't done any extensive testing with that, but I think generally there's probably a lot to be said for keeping if you can, resource-wise, keeping your graph analytic workload constrained to one machine if possible, because that cuts down on a lot of the intermediate kind of communication that has to happen. So I think, unfortunately, as I mentioned, the Fulgora graph computer is kind of a hidden secret, I guess, in the JanusGraph code base. It would be interesting to see if folks kick the tires some more and to hear what sort of successes or not that they had with it. But I think it's definitely worth exploring. The other thing we didn't really talk about but I think another interesting option with JanusGraph is, especially for data scientists, are used to using all sorts of other different interesting graph libraries, even outside of Spark, for example, like Network X. One of the things that we'd like to do is come up with a good set of instructions for folks to enable them to more easily interoperate with, say, those Python type tools. How do I export data from JanusGraph, load it into Network X? And then that's a case where the resources on a single machine, the more resources you have, the better. So.
Cool. I know Ryan has a hard stop at 10:30 Central. So Ryan, do you have anything else you wanted to add to the slides before you have to go?
I think his Zoom, he can't unmute his Zoom locked up, unfortunately.
All right, no worries. Well, thank you both. We'll keep doing a few questions, and Ryan, if you need to hop off, that's fine. Really appreciate you presenting today. Okay, so our next question is on Life of JanusGraph OLAP query slide. Is configuration of Spark cluster a JanusGraph deployment time configuration? Can I run an OLAP analytic to run on a standalone Spark cluster that does not know about my JanusGraph deployment?
Yeah, so the last does not know about. It needs to know about it in the sense that it needs the configuration information so it knows how to connect to it. So basically when you start a Gremlin graph computer job, part of that configuration in the little blurb I showed you guys with the where it's opening with the graph factory, it's opening a file up. In there's connection information to the JanusGraph cluster. So it needs to know where it is so it can go grab the data and pull it out of it. I'm sorry, what was the first part of the question, Ashley?
Yeah, sure. And you can also, I think, Ted, you have access to the Q&A box. If you want to pop that open, you can see this one too.
Oh.
It's the one from Julian. It says, on Life of JanusGraph OLAP query slide, is configuration of Spark cluster a JanusGraph deployment time configuration?
You can do it after the fact. So you don't have to do that. Like you could start out without that, and then you could add that on later on. So after you've deployed JanusGraph and say you decide I want to try this out, you can set that up after the fact. So yeah, you definitely don't need to do that right away.
All righty. The next question says, one of the issues I have been seeing since JanusGraph 0.1.1 is extremely painstaking OLAP setup. There are jar issues and version mismatch. Any plans to simplify that?
Yeah, that's definitely a common pain point. There's a few intersecting reasons why that's a problem, which I'm sure you're all too painfully aware of. But there's a lot of libraries in play when we're talking about JanusGraph OLAP. There's Janus, there's Tinkerpop, and there's Spark. And then in a lot of cases, folks are wanting to deploy these things to probably not just a Spark standalone cluster, but probably like Spark running on Yarn. That's definitely not uncommon. You basically have to, right now, and again, you probably know this, but everything has to be lined up perfectly pretty much, or you're going to have problems. There's not really at this point, you know, there's nothing going on that I know of to simplify that. I think it's pretty tough because all these projects do already have this set of dependencies in play. So I'd have to, you know, think about that. I think one of the things in Tinkerpop 4, like I mentioned, is there likely will be more execution engine options that may make a lot of these analytic type queries possible in a standalone Janus setup without needing to bring Spark into play potentially. You know, this is still pretty far off, so we'll see, but that may simplify things and at least serve a larger number of query types that it's hard to do against Janus right now.
Awesome. So we do have a few questions left, and if you are a panelist, you can see those questions. If you want to type out an answer while Aaron and Becky present, you are more than welcome to do so. Otherwise, we will get back to those questions at the very end of our time together. So I will go ahead and hand it over to Aaron and Becky, who are going to tell us about JanusGraph at Target.
Okay. Hey, Ashley, are you hearing me?
Yes, we can hear you.
Excellent, excellent. Looks like I'm having some trouble starting video. Are we not doing video right now?
You're welcome to do your video if you'd like. You don't have to though if it's not working for you.
Yeah, tell me the host has stopped it. We'll just jump right into sharing. No worries.
Okay.
All right.
So Becky and I are going to be kind of tag teaming this one, so we apologize ahead of time if there's any AV issues as far as you know, having to mute or unmute ourselves. So we'll try and keep that to a minimum to, like, you know, keep the feedback low. But essentially, what we're going to talk about is, you know, a little bit about NoSQL at Target. Specifically, Becky and I are on the NoSQL data store team, and we manage a lot of the distributed data stores at Target. And in particular, this presentation will be about our road to JanusGraph, and kind of how we ended up there and a little bit about how we deploy it. So let's get right into that. So some of you may not know who Target is and why we would need NoSQL, let alone JanusGraph. Well, the answer to that is scale. Target, sorry, everything's taking a second here to come up. We're actually a pretty large enterprise. We're number 39 on the Fortune 500. We're the 10th largest employer in the United States, actually. Our team falls under Target Technology Services, and we build systems that, you know, support various things, various tech in our 1,850 stores, our 39 distribution centers. We have daily guest interactions, you know, in our physical stores that number upwards of 30 million. So we definitely have a large scale that we're trying to deal with. And with one of our more recent projects, JanusGraph kind of solved, you know, some limitations that we had with our prior graph implementation. So anyway, we'll get more into that. Sorry, two of us on a keyboard here. Little about me, I'm the NoSQL engineering lead for Target. I'm a 3-time Cassandra MVP, and I've written a couple of books about distributed database processing. Most of them kind of center on Cassandra, of course. The 7 NoSQL databases in a week. I also wrote the chapters on Cassandra, Redis, as well as Neo4j. So I've worked quite a bit with you know, that tool. But like I said, we're kind of gravitating more to Janus at this point.
Hey, and I'm Becky Nelson. I am an engineer. I recently graduated from the TLP program for Target, which is the Technology Leadership Program, where they trained me up and let me experience a variety of different stuff. So that was pretty cool. And I found out that data source services was a good fit for me, so I ended up staying here. I'm the technical lead for Graph, and I graduated from NDSU, so that's neat. I've done a little bit of open source dev work with an organization that I work with, which is seeking to do some character-based personal assistance. And I also am a presenter at different fandom conventions. All right, so what do we have for data store at Target? Oh man, so the scale of what we work on is quite big. So when it comes to Cassandra, we're managing 21,000 nodes, 100 plus clusters, and a whole bunch of other things, as you can see from this slide here. And this isn't necessarily all of the databases that we handle, NoSQL at Target, because it's entirely possible for another team to go and create their own clusters, but this is what we handle under our team specifically.
So moving on to Graph at Target, Neo4j is the current CIO-approved offering, and it's I suppose you should talk a little bit about what that means exactly. Anyway, okay. So anyway, in an enterprise as big as Target, where we have more than 1,000 developers spread across dozens of teams, what we end up with, if we didn't have some sort of governance around like open source tools, it would be the Wild West out there. We'd have libraries and tools from basically anything you can imagine that would solve an engineer's problem being brought in, and that's on a large scale, that's really hard to manage. So there actually is some governance around which data stores we can use. Now Neo4j, like I said, is the current CIO approved offering. We actually it was brought in by our promotions team. It has some advantages where it's popular. If you look at dbengines.com, you'll see it's #1. And a lot of that is because I think it's very, very easy to get started with Neo4j. That being said, it definitely has some downsides. It comes along being difficult to scale horizontally. Even with an enterprise license that you get, and you're able to do some sort of like causal clustering with it. It doesn't necessarily scale as horizontally as you might need. And as you can see by my final point there, it actually does have a fairly high price tag to it that is something that in the long run we're looking to reduce our licensing costs, and obviously Neo4j is not going to be the future there. So real quick, just kind of go through a little bit about like graph use cases and data modeling. This slide in particular is more towards the graph maturity level that you see at Target. So when we have a graph consult, which we really only get a few a year, usually what it is it reminds me so much of this scene in the Matrix, in the second Matrix movie, where Neo and Morpheus and Trinity are sitting down, with the Merovingian and Persephone, and they say something ominous like, why we're here, and then Becky and I take the roles of Persephone and the Merovingian, and we're like, yes, we know why you're here, but do you? And what it really comes down to is that next line from the movie as well, where you think you do, but you do not. And you are here because you were sent here, is the line that comes after that. And the idea there is that there's a hard truth to getting started out in a large scale enterprise with graph, is that most teams will pick a graph database for the wrong reasons. And specifically, they'll pick it because somebody tells them they should, and they'll do it without really understanding why they need it. So that becomes a challenge as far as we're concerned with trying to guide our teams towards building good applications and using data stores that fit appropriate use cases. by and large, our teams have done a pretty good job, but we have definitely had some instances where there's been additional coaching required on that.
All right, so as the technical lead, I take a little bit of point on this for Graph and talking to guest data platform. What does that mean exactly? Things, they do things, great things. I wish I could talk more about what they do, but they do good things. All right, so what happened is they originally came by and they said, you know, we've got what we believe to be a graph problem, and we're going to need a large Neo4j implementation, you know, because it's going to be really big. So we want to go really, really big. And by the way, we need an enterprise license for Neo4j and enterprise license usage. And we said, well, that's a lot of dollar signs on there. So maybe let's take a look at some other alternatives and see what we can find. And that kind of kicked off our entire process for looking at JanusGraph and starting to dig into it and explore and see all kinds of awesome, fun things that JanusGraph could do for us and for GDP. So why JanusGraph as opposed to anything else? So Janus, coming from the Roman god of beginnings, gates, transitions, dualities, doorways, passages, and endings, sometimes Janus, because these are the Romans, and they didn't always have J's. Sometimes there were I's in their alphabet, and that's fine. We're kind of call it Janus now. So the thing about Janus that makes it so awesome is that it supports so many, just out of the box, out of vertices and edges and thousands of concurrent users. It really hits that scale for us that we need. And the best part is it's open source. That's awesome. It's distributed. That's more awesome. All right. So that seemed like a good fit. That seemed like we would like to actually dig a little bit more into this. Let's try out an implementation of this. All right, let's move forward. So we decided to get the GDP team set up, and we said, all right, we're going to start you off with JanusGraph 0.3.1, and we're going to give you a backend of Cassandra for data, and we're going to give you a backend of Elasticsearch for indexing. They were looking at around the ballpark of 120 million nodes, 600 million nodes. That generally tends to shift a bit. Those businesses sometimes do, but we did eventually end up settling on about that for our initial deploy. So what is it going to look like when we deploy? I did talk a little bit about this in some of the answers, but I'll continue to actually go into detail about what we do. So we have an application that's going to connect to a load balancer, which will be sitting in front of several instances of JanusGraph server. Now, we separated out the storaging and indexing backend in order to have them all be acting as several points of entry into those storage and indexing backends, but working with the same data, and that way we could also leverage stuff like Spark to operate on our backend.
So one thing that was kind of missing from like the overall JanusGraph stack that we had started to put together, and one thing that a lot of our teams really liked about Neo4j was that it comes with that visualizer kind of integrated in. It all comes in that one package. So we went kind of looking around trying to find a good visualizer that would work for us, and I stumbled across GraphEXP. More specifically, we stumbled across Armand Leopold's fork of GraphEXP. And the reason for that is that had, some more customizations around like what you could do in terms of, like different colors for nodes. It had the curved lines as far as, being able to show edges. That way, if you had multiple edges, it would kind of increase the arc, and you'd be able to kind of see that a little easier. And this screenshot of it is just a quick example graph that I put together to kind of demo some of the capabilities of graph technology in general. And what I'd done is gone out and gotten a CSV of NASA historical astronauts, and basically put that in, and this allowed a quick query of, hey, show me the astronauts who flew on Apollo 13, and we were able to kind of pull that together pretty quickly. So anyway. So things were kind of going great until the last presentation that Ted and Ryan, I think, were talking about. They mentioned a lot about like Spark integration and trying to put that layer on top of JanusGraph, and that was something that I guess we really hadn't anticipated the problems with, but that was certainly something that our dev team ran into that that Becky and I kind of had to put some thought around how we were going to solve that. And the other issue we hit that was sort of important especially in an era where, we're all looking to tighten up security on, our tools that we use both internally and externally, is that the graph visualizer that we had, GraphEXP, had no auth layer whatsoever. So that kind of presented itself as a bit of a challenge to how we were getting going.
Right. So then again, we're talking a little bit about thrift and the problems that we're seeing with that. So they came to us and they said, hey, we want to use Spark for data analytics, as one does. And we said to them, that sounds great. You want to use Spark? That's awesome. Go ahead and use it. Let's try to get this set up. Well, the problem is that at the time, the Spark Graph Computer appeared to require Thrift protocol to be enabled on the Cassandra cluster. And we're trying to move away from Thrift. It's not the recommended way to use Cassandra. And so we said, okay, well, maybe we can keep it on and still keep the CQL connector running, and we can just have Thrift and the CQL connection active. And as it turns out, no, that was not working for them. They were running into very strange data inconsistency problems. We're still not exactly sure what the source of that is, but it basically came down for them to ask us to have Thrift only on Cassandra, and that is not something that we were entirely cool with doing at the time. So what did we do? Well, we had a problem solved for us, because JanusGraph 0.3.2 came to this and said, yeah, we're starting to test out some actually enabling CQL on Spark Graph Computer, as well as JanusGraph 0.4.0 addressed that definitively for us. And so we just ended up doing a version upgrade and avoided that problem. So that was awesome. And yeah, it was awesome to see that was getting integrated into the main JanusGraph code base.
So the other issue we ran into was the fact that the visualizer, as I mentioned, didn't really have auth enabled. And the thing is that neither did the main repo either. So that was sort of an issue that we were presented with. And again, this is an issue that cluster, is designed to serve guest data, and that's obviously something that we wanted to get in front of and be able to tighten down. So what we ended up doing was forked our own version of it internally, and someone on the development team actually had a good background in JavaScript and went ahead and added WebSocket authentication on it. That is something that we'll, look at open sourcing, in the future, because, I'm sure there are others out there who had this exact same problem with a GraphEXP visualizer that, they'll probably want to be able to implement authentication as well. And I was really glad that, our dev team, and again, we kind of worked in a partnership with them on this whole initiative. And it was really cool that our dev team stepped up and was able to do that. I kind of look at JavaScript like I do Perl, where it's, something I can do, but, if I can keep it at arm's length, I definitely will. So anyway, that was how we got around that. And, they were able to go forward from there.
All right, so as I mentioned before, we are now running on JanusGraph 0.4.0, and we've got 4 JanusGraph nodes, 6 Cassandra nodes, and 5 ES nodes. Although we've looked into upgrading the ES, so we're probably going to be moving to 8 in the near future, because we found that 5 isn't quite hitting that sweet spot for us. But yeah, that is our final environment for this. This team seems to be using it well. Things seem to be going well for them. Performance on Cassandra seems good. We have gotten blocked a little bit by performance in Elastic. So again, we're thinking about expanding that out. All right, so what I'm going to do for you now is I'm going to go through a real brief summary of a demo of provisioning for us. And how that is going to work is we have a system that we use called RunDeck for provisioning that allows us to keep our scripts all in one place. It allows us to repeat provisions perfectly, hopefully. Not always perfectly, but we do our best. And if I can get this to pull up here. All right, so I've got a little bit of information here redacted just because we can't be talking about everything here again, but cool stuff. All right, so I just got a bunch of pop-up notifications from Zoom. Can you all still hear me? Okay.
Yeah. Mm-hmm.
Excellent, excellent, excellent. Okay, so what we have here is an example page well, starting page for provisioning a Cassandra cluster. In this case, it would be a very similar interface when we're provisioning a graph. We'd basically enter in, hey, what is the thing called? What or some a little bit of details. In our case, it would be some certs and some other authentication info. So then we would hit run the job. It would go run through. Oh, why can't it be bigger? A little bigger. Close enough. It goes ahead. It creates the server. It says, okay, I'm going to create a VM. I'm going to create a floating IP, throw it on there. And after that, we run our installation job, where again, it will go through. It'll start adding the certificates, our key files, Cassandra Trust Store for talking to Cassandra securely. It does a quick check to make sure that the things that you've sent it are good, because it would be horrible if we started out a job with everything just failed halfway through, and we'd like to fail fast. So it runs through, installs JVM. This is an idempotent job, so it will try to remove everything first to make sure that if you run it again on something that already has it, it doesn't just break. Then it moves on and installs the JVM, installs JanusGraph, installs Telegraph and JMX Trans, which you use for metrics. And that's it. At that point, it will try to do a restart of the system and try to do some initial user modification. That was a little bit tricky for us because we had to just start piping data around, but we made it work. And that's it. It's done. It takes the entire process from creating all the Cassandra clusters, all of the Elasticsearch, and all of the JanusGraph takes around, I would say, about an hour at most for all of that, depending on the size. So yeah. All right.
And then, just to add to that too, a lot of what we had wanted to show today was more around kind of how we deploy. Again, our team kind of focuses on building out managed database services for, the target development teams, and being able to put a lot of automation around our deploys and, how we kind of build things out is really something that we do a lot of. We're firm believers in the motto of infra as code, and that's something that we do quite a bit of, actually. So I think that about does it for what Becky and I wanted to show. Is there yeah, I guess we can go to questions.
Awesome. Thank you so much. That is really interesting and lots of things I didn't know about Target. So very cool. Okay, so we do have a question here. Raha wants to know if you can talk about any specific use cases at Target. I don't know if those are top secret or if there are anything you can share.
Yeah, there is a lot of that is our what we would call our secret sauce and our competitive advantage. So I can't give away too much. However, I can think of like 3 off the top of my head that I know are pretty common for what what we see out there. One is we use it for like our internal like tech asset management. So like a CMDB, if you will, where we're we're out there mapping out applications and how they relate to things like Cassandra clusters and Kafka clusters and other infrastructure as well. That way we can look at it and say, hey, if we have to go ahead and we have to upgrade, like this Cassandra cluster, what does it affect? And we can kind of get a view through our graph, like what effect that's going to have and kind of what the blast radius is, quote unquote. And there's another one too where we use it for I'm trying to remember, it's like the logistics and transportation team. They use it to kind of map out, I think it's like mapping out like routes for our trucks, because I'm sure that those of you who live in the US around like larger cities have seen Target semi trucks basically going from our DCs out to our stores, and essentially they use that to kind of I don't know if it's the shortest path or best path or what the actual algorithm is that they're using there, but essentially they're trying to get our drivers the most optimal route, but they have to go from a DC to multiple stores and try and figure out the best way around that. And then specifically the one we mentioned here with the guest data platform, that one I can't get too much into. In fact, the funny to note, the guest data platform actually heard that we were doing this through the JanusGraph community and wanted to know exactly what we were sharing. It's funny how that worked. But essentially what it is just at a very high level, it's something that we use to kind of monitor and analyze shopping habits and patterns of our guests by household, I think is how they're looking at it. So just at a real high level.
Yeah, definitely. Well, thank you for sharing what you can. It's cool to see how JanusGraph is actually used in the real world. So another question we have here is, what was the ingest rate of getting the nodes and edges in that setup?
Ooh, I remember a little bit about this going back and forth. Becky, do you know any more about what they might have been doing here?
I don't have an exact answer to this question, but it's a great question, and it's definitely something that we like to keep tabs on in terms of metrics for the future.
Yeah, kind of along those lines. I was wondering, when folks come to you, is there any kind of set of things you kind of set them up to start monitoring right away? I know I saw in the you're hooking Telegraph up and grabbing JVM stats and stuff. Are there any other things you found particularly helpful to watch?
So we're still very early in our deploys, and we're still trying to get the feel for kind of what metrics would be the best to watch on. But we have some real basic things that we can do that kind of like generically work for everything. So it'd be just like your typical, hey, how much memory is the JVM using? How well is the JVM itself performing? But we haven't really zeroed in on something that is real JanusGraph specific yet. Honestly, we have more experience with Cassandra at the current point in time, and so a lot of our monitoring tends to be around the Cassandra cluster that is backing us, making sure that looks all healthy.
Awesome, cool.
Yeah, to kind of echo what Becky was saying there is that we do kind of watch things mostly on the Cassandra side to be able to address the health of what's going on in the Janus world. Specifically, we'll look at things like CPU spikes, and we'll look at read and write latencies to see if that's, coming through at appropriate levels. And also disk IO latency as well, just with our internal cloud. We've had a couple of issues here and there around that, but by and large, it's been going pretty good. And, to Dion's specific question around the ingest rate, I know that Becky and I don't have that information in front of us right now, but I do know that they were going at a pace of, I don't know about edges, but I thought I saw that they were doing somewhere around 4 million 4 million nodes a day, something like that, 4 or 5 million. I think if they were running that, that loading job throughout the day. So that's my guesstimate there.
Yeah, that sounds reasonable to me.
Wow, very cool. Okay, if you have any other questions for Aaron and Becky, you can submit those in the Q&A box. For now, we are going to move on to our next speaker.
And today I want to talk about some of
Hey, Rick.
Yes?
Sorry, we couldn't hear you. You were muted. I just unmuted you. Can you start over?
Okay. Yes.
Thank you.
Hi, I'm Rick Paiste. I'm a graph architect, senior graph architect with Expiro, and today I'd like to talk to you about some experiences I've had of modeling entitlements and authorization and access control at the enterprise level for in JanusGraph. So with that, I'll move on. So today the agenda is to do a quick overview of what entitlements means. Look at a model a graph model for entitlements, and walk through some use cases and some lessons learned in doing an implementation that could be beneficial to everybody. So for me, entitlements is really about the intersection of parties, and parties may be people, or they may be organizations, or they may be other structures that own or maintain applications and access to resources. And resources in the case of a financial institution may be accounts or account groups or financial instruments, or in the case of just an IT environment, it may be files, it may be specific rows in a big data set. It could be anything. So just generically, it's a resource, and we want to control access. And we want to control access in the context of an application. So in some contexts, an application is allowed to read and write to that resource and in the context of another application, it's only allowed to read. So managing that at a comprehensive view for the enterprise is the desire here, so that you don't have to go to each and every individual application store and manage that data, using provisioning systems. So the idea here is to pull it all into a single graph, get a single source of truth, and use that single source of truth for audit and for automated provisioning. So instead of taking weeks or months to onboard a new person, you can provision them instantaneously, because you have the rules defined at a meta level that then can be projected into the target systems. So the next step is, how will we take this simple Venn diagram and project it into a graph? And here we have a tool that we use internally to work with Janus. And here you see modeled a very simplistic model of what was represented in that Venn diagram. And we've actually dropped application out for this particular use case, because we were projecting a data source that didn't have an application. And here we have the parties, we have the edges, the managed by edges, the child of edges for the nested parties relationships, like organization has departments, has people. Same thing with resources. You may have a group of resources that you want to grant at level at, like you would in Active Directory, or individual discrete resources, or even specific rows, etc., fine-grained access as resources. Then the idea of a profile, which is a way to manage a collection of resources that is managed by a party and grant it to multiple identities. So a resource may have multiple identities. As an example, I may have an identity that's a Google identity, and then turn around and I also have an AD identity, and I want to be able to access these access this graph through access this authorization scheme through any one of those identities. So back to here, another example of a resource are accounts, account groups, and financial services. And we have profiles, like I said, is access to the accounts. And then identities, like I said, I can have multiple identities, and separating them out from the actual party, because a party is an owner of the authorization scheme. An identity is simply a proxy used to authenticate against and be able to ask for access. Slide through here. So some of the traversals that we do is, can a given identity access the account? And by modeling this in a graph, it becomes a very simple traversal to ask that, to inquire what accounts does a particular identity have access to. And as you can see here, here's the Gremlin traversal for it. And it's much easier to do this than possibly dealing with LDAP as an example, given that these resources may not be able to be modeled in LDAP. Another example of a traversal is, who all can access this account? So when you're doing an audit, you look basically from your resources back to the people or the identities that can access them, and you want to be able to quickly determine who has access to what resources, because what you might find sometimes is that system admin people, as an example, may have greater access than maybe your execs do. So it's important to be able to slice and dice and look at through your graph at all these relationships and quickly determine what not only transactionally what you have access to, but also from an analytics perspective, what people have access to what resources, and mine the exceptions. So in doing taking that model, and I walked through it very quickly. I think this is back to the lessons learned. I think the challenges here is that, so the goal being that you want to model the semantic relationships of the organization, project them into a JanusGraph graph model, and then be able to provision the APIs that execute those queries and ensure that they are performance. So when you're doing this and working with customers, you find that you really need to make sure that the success criteria is clearly articulated. In the case of one of our engagements, we had the success criteria is we had to have a graph, a very large graph, that had to support a volume of 7 to 10 years worth of data in the graph, so that they could walk analytically back through time to see who had access when. So there were some temporal aspects to the graph store. We had to have the audit trail. And we also wanted from an audit trail to journal all of our transactions to the graph to a log-based storage, so that we could always regenerate the graph at any point in time to guard, from an audit perspective, to guard that in case there's an issue with the projection into the graph. Our SLAs were stringent. We had SLAs for those transactional queries I quickly went through, like the accounts that an identity can access of 50 milliseconds or less, given realistic transactional loads. So fairly stringent criteria. And then a P99 of 100 milliseconds. We built REST APIs to do our work on top of this graph API. And we need to support the growth and extendability of the graph model. So as new business units are added, or new applications or new problems are added to this system, we needed to be able to model those new relationships, semantic relationships in the graph. And the graph really allowed us to do this, where a projection onto a relational store would be very difficult to extend in a clean way. So the graph really brought us that flexibility. We had to be able to support housekeeping, so through UIs and APIs. So administrators need to be able to come in and do diagnostics when people call in and they don't have access to the resources they expect to have access to, or there's a failures being thrown off in the log managers. And the intention here at the API level is to be able to drape over a base model abstractions at the API level that are then projected into the gremlin into a more generic graph model. That's the notion of snowflakes here. And then the platform we've worked with here was a JanusGraph cluster sitting on a Cassandra data store. And it was optimized for operational transactional gremlin, search, and then analytics last. So one of the lessons I've learned is with all of this is, you build your graph, you have your data sources, and you're getting the single source of truth, and you're pulling all this data into a graph projection of your entitlements. And you really, really need to understand the dimensionality of your data. Because if you don't understand the data, it's going to influence how your traversals is. So it's basically the projection, but also how your data has been projected, and understanding the cardinality of that data is really important in meeting those SLAs. And in order to do that, you have to do analytics on your data sets, and either doing graph analytics after the data is loaded in the graph, or doing the analytics outside. But you have to analyze the data, understand what's there, and you have to instrument your code. You need to set logging in your code, gather timing information of where things are worth spending its time, and with that information, you can start to really get introspection and understand how to tune your system to meet the needs of your SLAs, to meet your demands of your SLAs. So one of my lessons learned in this whole thing is that, you have this large test data set, and if the tests you're writing are a subsample of your overall data set, so you've loaded your entire data set into your graph, and you're going to test it, and this data set is reflected. The data is going to look like in production. That's very important. Statistically, to do that. You also need to build your tests to reflect the transactional load characteristics that you're going to see traversing that graph. So if you just randomly grab things, you'll find in this particular case, we're looking at an identity and the number of accounts that a particular identity has. And you'll see that it's a log normal distribution from left to right. And, most identities have access to, 4 or fewer accounts. It's a small number. But then there's a few that are distributed over here that have, access to hundreds of accounts, or possibly thousands of accounts. And in that case, that's going to impact your performance as you're traversing in your graph. So what's important is that you take this test data set, you generate your tests that you're going to execute. So let's just say the identities here, and you have that distribution of that identity set reflect the reality of the real use cases. If you do that, then you can model real SLAs. If you don't do that, number one, you may encounter difficulties achieving the required SLA, and you also may run into issues where you're significantly beating the SLA, and you put it in production, it's going to break. So, lessons learned here is you can do all this if you properly understand your data. You can do all this testing up front, and really, when you roll with the production, you're not going to have SLA failures. You're going to know the edge cases. You're going to know everything about your data and what your expected performance characteristics are. And we do that kind of performance assessment using Gatling. Gatling is a great tool. You pull together your traversals. You can run scenarios that are reflective of the real utilization, and from that, you can go back and see how if you can achieve your SLAs. So, in the case of the work that was done for this particular engagement, was will it be fast enough? And we had a SLA of 95% under 50 milliseconds and 99% under 100 milliseconds or less. In our case, we built REST APIs using Spring Boot, so they were Java APIs, and we certainly had unit tests for all of our results, but unit tests are only a smoke test that your traversal works. It has absolutely nothing to do with performance profiling. And we found that you could do some profiling in the Gremlin traversal, but really the best way to do this is you come back, you instrument your code with logging and timing You monitor your cluster and profile your services as they're running, and you run multiple regressions using experimental methods. So you really need to hold down your controls, your experiments, and your known data sets, and treat this just like you would any other real experiment. And doing this, we found that we were able to achieve scale with Janus and Cassandra in the context of an entitlements engagement. So projecting authorization and access control onto a similar graph model, not this exact graph model, but a similar graph model to meet the SLAs and provide these SLAs are used by a API gateway and consumer-facing API gateway to test what resources a particular identity has access to. Lastly, this is an example of some scalability results, and this particular scalability run was with this actual graph demo that's here, graph model I've shown you earlier, running against a Scylla cluster, and with Janus sitting on top of it, and we were able to, in this particular instance, test the number of resources that a particular identity has access to with 10,000, a load of 10,000 concurrent users through a API, and we had P95s here in the order of 23 milliseconds. We failed in the 99th percentile, but in the 95th, we were still 23 milliseconds. So it's pretty snappy. So we really believe that this is a great way to model your data, to your entitlements data, and have a single enterprise view of that data that can be used for transactional loads, support both transactional loads and analytics loads. And on to questions.
Awesome. Thank you, Rick. That was really cool to see that, JanusGraph can be used for all sorts of things, from target to entitlements. And if you have any questions, now is the time to ask them for any of our speakers. I'm going to go ahead and go back to our Q&A box here. There was one question that got answered live that I just wanted to, or got answered via text in the Q&A box that I just want to read out loud real quick. This says, a general question to all the speakers: has anybody used or heard of JanusGraph in production provide below low latency reads, say 10 to 30 ms? I've been asked this question many times. Can JanusGraph work for extremely low latency use cases? And if you want, you can read some of the answers that were typed out there, or if Ted or Rick, if either of you have something you want to add, you can do that.
Yeah, I think Becky had a real good answer, thorough answer on that one. The classic engineering answer where we always say it depends,
Right.
which is 100% correct.
Yeah.
So yeah, definitely, yeah, go ahead and read that if you're interested, folks, because that was a really good response. So
yeah. Okay, the next question we have here is, do we have any ideal production deployment architecture diagram, recommendations on security, availability, and performance, etc., for production implementation?
This is a good question, and again, it depends. Largely because, as you all can imagine, one of the strengths of Janus is its ability to support different storage and indexing backends, but at the same time, that adds a lot of options for folks. So your ideal setup is going to be probably determined by a number of different factors, all the way from kind of soft organization type factors like, hey, what does our operations team already support? Are they willing to take on a new storage backend? So if you take the Target example, like Aaron and Becky, they have a ton of experience running Cassandra, and probably can run Cassandra better than pretty much anyone. So running Janus over there on top of Cassandra is an awesome fit. Other folks maybe have a ton of HBase experience. So in that case, it's probably going to be best to start out with JanusGraph on top of HBase. Or if you guys only run in the cloud and not, on-prem. So once you figure that out, a lot of the characteristics of what is the best setup for security, high availability, et cetera, are going to come from your storage and indexing choice. Now, if you look at JanusGraph itself, each Janus instance is essentially stateless because all the communication to the other Janus instances happens through the storage layer. So high availability setup there is going to be running more Janus instances. For setting up security, you can reference the Tinkerpop docs for that to learn about how do you secure from the driver, the driver level to the JanusGraph, which is running really Gremlin server. So best practices there are going to be defined in that documentation. So that's a very long-winded answer, but it's largely a function of the storage backends and indexing backends that you choose as far as what kind of the best practices are going to be. So I would look at the best practices for those backends to get started.
Awesome. Rick, I was hoping that you could talk a little bit more about the benefits of visualizing something like entitlements and ID management using JanusGraph. What's great about being able to do that?
Well, by putting it into a graph and having a graph visualization tool layered on top of it, it becomes easy for someone to do a visual audit and see all the interrelationships between identities and the resources they can access and the parties that are related to that, which is the graph projection from a visualization perspective is superior to what you would see in a tabular projection that you might see with a relational store. So it really helps to navigate. And if you have an interactive type visualization tool, it's real easy to click on a node and continue to walk the subgraph out to quickly assess in an ad hoc way what a person has access to. That's the advantages.
Yeah, definitely. A follow-up question to that: which visualization works well for 100 to 200? I'm not sure what the big M stands for. Data.
Million, probably.
Okay, a million.
Probably a million.
Yeah.
A clustered visualization is going to be what is the answer to that. So you'll have to cluster your visualization down into common themes, and then you drill down into those clusters. I mean, you're not going to dive into a subgraph of 200 million vertices and edges. It's just going to be a mess.
Yeah, one of the things we end up doing a lot is something called progressive disclosure. So basically the idea there is, if you just, you probably have heard the term before, seen some examples of this where somebody tries to visualize some large number of nodes that could be much below that threshold even, and you end up with a hairball. Basically it's just going to be a mess. A human's not going to be able to make any sense of it. So like Rick is suggesting, and whether it be starting out at a higher level, like looking at clusters, or maybe even starting out with a visualization that's not a graph, but provides summary information. The idea is you give the user an ability to then drill down and find what they're really interested in. Even if there somehow magically was a way to render, 200 million nodes on your screen, it's incomprehensible to a human. So what you really want to do is figure out, okay, what is the end user actually going to use this graph visualization for? And then there's not going to be one visualization. It's going to be a series of steps where the user can drill down to get what they want. But each level is still going to be providing them some sort of information, some very aggregated information, probably at the top, all the way down to the bottom where you can actually, okay, now I'm actually looking at some subgraph that I can digest.
Yeah, cool. All righty, well, Ted, I am going to turn it over to you to go over our upcoming events now. And while we do that, we do have a poll for all of you who have joined us today. It's just a quick 7-question poll. We just want to get some feedback from you guys, and we'll give you some time to answer that. I'm going to launch it now. So you should see that pop up on your screen, and you can answer those questions while Ted goes over JanusGraph news.
Cool. Thanks, Ashley. Yeah, so as I mentioned, we have 2 new releases out, relatively new. A big thanks to the release managers and all the folks who contributed to these. Really great list of new committers and lots of good activity in the community as we gain some more popularity. You can find these up on the GitHub JanusGraph site in the releases section. So definitely encourage you to check them out, or if you're already running Janus, lots of good bug fixes and performance fixes too, especially in 0.40. So probably worth evaluating if you want to upgrade. Upcoming events, there's some cool upcoming graph events. I wanted to mention big thanks to Jason Plurad for pinging me about ApacheCon. So ApacheCon North America 2019 is in September. I think it's in Vegas. There's 3 graph-related presentations. One is actually JanusGraph specific. Nordstrom is going to be discussing Janus, how they use JanusGraph. And then, as I mentioned, there's been a lot of work going on in the Tinkerpop 4 world. So this should be really cool. Marco Rodriguez is going to do a presentation on that. And then there's a Sparkle presentation also there. Sometimes we get Sparkle questions, and there's actually some Sparkle Tinkerpop capabilities now that are pretty cool. I don't know if anybody's actually using that with JanusGraph, but if you're interested in Sparkle, you can check out the Tinkerpop docs to read a little bit more about some new options there. And then we have the Global Graph Summit, which was called previously Graph Day, but Global Graph Summit 2020, which is part of Data Day, which is in Austin, January 25th of next year. This is usually a really cool get together, lots of different folks. Right now on deck for that, again, Dr. Marco Rodriguez giving the database keynote. Joshua Shinavir, who's a Tinkerpop committer, is talking about Tinkerpop, and then I'm gonna talk about something. We'll see what that's gonna be, but I'll talk about something probably JanusGraph related. So
Nice.
Anyway, that's what we got coming up.
Awesome. Okay, well, I'll let you take a few more minutes and finish up the poll if you have not already. I'm going to do a quick recap of our speakers. We had Ted Wilmes from Expiro and Ryan from Enharmonic. And then we also had Becky and Aaron from Target. And then finally presented was Rick Paiste here from Expiro again. So if you have any questions that you think of after our session today, you can feel free to respond to the email of the recording that I will send out to each of you shortly. Thanks so much for joining us today, you guys. Hope you enjoyed it.
Yeah, also just to add, I follow the JanusGraph, user mailing list too. So if you have questions too that are specific to what we talked about, you can post them there, and we can answer out there as well.
Yes, thank you for mentioning that. If anyone on the meeting today is not a part of the user group, can you tell them how they can join that?
Okay, I'm trying to remember how I joined it now.
It's been so
I think
long.
there's a link on the main JanusGraph site that takes you there, if I remember right. It's been a while.
If you go to JanusGraph.org, yeah, there should be a link to. It's like we run all of our user groups are on Google Groups, so you can also just search for. There's a JanusGraph user Google group and a JanusGraph dev group. So depending on what level of things you kind of want to keep up with, if you're interested in what's coming down the pipe, you might want to also get on the dev list. But you can get on those lists up on Google Groups, and yeah, there's some links up on the JanusGraph.org. We also have a Gitter set up, so if you want to do a live chat, there's usually some folks and some activity on there too. So.
Thank you, Ted.
Awesome. All righty. Well, we'll give you back the rest of your day. Hope you have a great week. Bye, everyone.
Great. Thanks, everybody.
Thanks, everyone.
Thank you. Bye.